In the C2 and malware development video, we discussed about Petaq implant and Petaq service and how we can compile them in a Windows. This is the Windows development desktop. However, this time we need to run this on Kali Linux, and that's why we need something else to deploy this implant on this Windows. We need a couple of adjustments here. First, we need something lighter to deploy. This developed Petaq dropper. This is a simple dropper and it will work just like this. We have an Excel file that we will discuss in future slides. And this Excel file will run the Petaq dropper. Petaq dropper is a C# application and it loads the MC patcher we discussed in our previous MC bypass. And then it also loads Petaq implant and it lets Petaq implant to run the application. And starting from that moment, the Petaq service will drive the Windows 10 through this Petaq implant. So our step is currently deploying a Petaq dropper that can load and run MC as well as load and run Petaq implant. The minor adjustments here are, first, the Petaq service needs to have some port adjustments. You can get the Petaq service and Petaq implant using the git clone command. After that, the clone will create a repository in your folder, which is right here. And Petaq service is our service component, and you can enter like that. And this configuration under properties launch settings will give you option to change the port address, IP address and port. The port is simply port 80, port 443, 80 for HTTP, port 43 for HTTPS communications. And in this case, we can only use .NET Run to start this service. So I'm just hitting it down, and .NET Run is here. So simply, we will wait for an implant to connect this environment because currently there is nothing connected. Let's discuss about Petaq dropper and how does it work. First of all, it's quite simple and it does do something quite generic. Assembly load. Assembly load is available in system reflection, and system reflection allows us to load an assembly and run its methods and time part of our own assembly and our own process. That's why assembly load currently loads the bytes and assembly given, and it gives us an ASL assembly .NET variable. And through that, we can get the types, we can get the methods, and with some parameters, we can run them. How I implement it here is quite simple and available in MSDN as well. I get the type as well as method. They are class as well as the entry point. As we will work with the DLs, there will be no entry point. That's why the entry point will be decided by myself. And this is also accepted as parameter here. Name and method name. This one is the parameter section, and I do not give any parameter here. I will run them as is. Invoke will run this for us using the instance as well as the parameters. If we use threads, they are also available here, but in my current implementation, I prefer to not use threads. I'm going up, and now how it works. We have a URL, which is our Petaq service. This IP address is available on our Kali Linux. And this is the IP address used by Petaq service. And Petaq service serves the tools folder as a web page. So simply whatever we put under tools, they will be available, just like any web page. But if we have connections to /ws, it is WebSocket, and it is the CD communications. So what we have here is two different assemblies. I created an array here. The first one is the PA, the assembly name. The type is A, and method is B. This may be familiar because this is MC patch. Its class was A, and the endpoint point was B. PI is the Petaq implant. I have compiled this on Windows, and I can compile this on Linux and Mac as well, but it needs manual adjustments. That's why I prefer you to use Visual Studio to compile this flawless. So Petaq implant type and main is its starting point, enter point, the function. So this function simply new web client, and using that web client downloads the assembly from remote using this URI, and it introduces this assembly using execute assembly functionality. The data will be the assembly bytecode. Simply, they are byte arrays. And assemblies I1 and I2, they are the actually types and methods. So simply, this binary, this .NET assembly will run. The web client is generated using this function. The key things here are, first, the user agent. User agent is coming from Microsoft Edge. And also this client, while generating, uses the proxy settings of the user, as well as if the proxy needs credentials, it gets the credentials of the user from the cached requests. So this is the code, and we expect this to run on this Windows side as the dropper to load the initial assembly, which is MC Patcher. After that, loading the Petaq implant and giving the application flow to Petaq implant and start communications with Petaq service. That's how it works. Now, we need to compile this. On Kali Linux, you can compile this Petaq dropper like this. And you can also deploy this to www tools folder under Petaq service. I copied this as PD. So the question here is how we will run this. On Windows, as we have seen in our MC bypass video, we can use PowerShell to run this type of commands. Because PowerShell supports system reflection because it is also integrated to .NET, and system reflection can be also used under PowerShell. What it does is quite simple. Using a web client and this URI gets the assembly from remote, PD, and PD is our Petaq dropper. I'm going back to service and showing that there is no implant here. And this bytecode coming from that URL will be loaded as system reflection assembly load, and then we will get the type, and we will get the method, and no parameters to run this. As you can see through the debug messages, Petaq implant is running. It simply executed. It executed our Petaq MC patch as well as implant, and after that, implant is connected to our service. And when we use list, we will see this service. The magic here is this command. So we need something that can replace this command because we don't expect user to type this. But this can be exactly changed with different things as we previously also discussed. One of those is install util. Another one is MS, also used for task management, and PowerShell, different functionality type, for example, for the source code, as well as we can use the living of the land beans. And moreover, we have some utilized through scripting. All these are currently running with Windows Defender, which is updated recently today. So we will replace this. In our example, we need to replace this using an Excel file because TA505 has used an Excel file with DDE. A macro will be a really good fit in this case, and I will use an Excel file with a Excel 4.0 macro that introduces the Petaq dropper to complete the rest of the flow. Now, we won't use this PowerShell command, but you can use this as a test command. So we will continue how we can do this all simple operations between Kali and Windows in another video.